Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our Pyspark course where we're going to learn how we can use Apache Spark with Python. In this lecture, I'm doing a project preview of what you'll learn in this course. We're going to do a crash course on how we can create data frames with Pyspark. So we are going to learn first how we can find and load data via a CSV file. Then we're going to learn how we can convert it to a data frame with Spark and Python. Then we're going to learn how we can perform different operations on that data frame. For example, how we can format it, and as well, how we can add new columns to it. And furthermore, how we can format all of the different values, such as how many decimal places per number. We're also going to perform different mathematical operations like getting the average, getting the max and min, and filters as well. We're going to learn how we can query our data frame for any kind of operation we want, such as getting correlations and grouping our columns and our rows into years or months, and using a lot of different functions and filters. Being able to work with data sets, databases, and data frames is very important if you are applying for any kind of software engineer or software developer role, because typically you will get asked to prove your knowledge of working with data. For example, you'll often have to be able to take an Excel sheet or any kind of table like data and extract valuable information from it, such as finding an average or even something more complex than just the average. And as well, you'll often be asked to link different tables together. That's also commonly asked, having to work across a whole database. For our course, we're going to show you how you can perform fundamental operations. So even if you have no experience, you'll be able to follow along with this course. This is going to give you a great starting point for working with data and data frames. I'm very excited to take you through this valuable topic. It's going to be a great skill set to have. It's very much in demand and you need to know. Awesome. Okay, so join me in the next lecture where we will continue the course. Hello everyone, and welcome to our course. In this lecture, we're going to jump right in and learn what is Apache Spark. All right, so Apache Spark is an open source unified analytics engine specifically built for large-scale data processing. And in this course, we're going to learn how we can use Apache Spark with Python. This is a module known as Pyspark. We're going to use Spark with Python to have a unified analytics engine for big data processing. With Apache Spark, we have built-in modules for streaming, SQL, machine learning, and graph processing. And in this way, Apache Spark has the highest potential to bridge big data and machine learning. Apache Spark runs fast. It's up to 100 times faster than traditional Hadoop MapReduce. And this is due to in-memory operation. As well, Apache Spark offers robust, distributed, and fault-tolerant data objects. These are known as Resilient Distributed Datasets, RDD, and we'll talk about what those are in the next lecture. As well, Apache Spark has APIs, application programming interfaces, for Java, Scala, and Python. You can cache datasets in memory for interactive data analysis thanks to Apache Spark. This means you can extract a working set, cache it, and query it as many times as you need. As well, Apache Spark integrates with machine learning and graph analytics through supplementary packages, for example, mlib and GraphX. Apache Spark has Python integration, which is what we are going to be using in this course. This is known as Pyspark, and it is an interface. It allows you to interface with the Spark framework. You can manipulate data at scale and work with objects and algorithms over a distributed file system. We're going to learn how we can work with a spreadsheet in this course, how we can get data and then turn it into a data frame with Pyspark, Python, and Apache Spark. Then we're going to learn more about how we can work with the data frame and query it as well as manipulate it. And that is Apache Spark. Join me in the next lecture where we will dive deeper into what is a resilient distributed data set. Hello everyone and welcome back to our course. In this lecture, we're diving deeper into a bit of theory about Apache Spark and overall understanding before we start coding. We need to know what are resilient distributed data sets, which are a fundamental object of Apache Spark. So an RDD, a resilient distributed data set, is a fundamental data structure of Spark. It's an immutable distributed collection of objects. So that means it cannot change, it's immutable. And it's distributed collection. It can contain any type of Python, Java, or Scala, including user-defined classes. Each data set is divided into logical partitions, and these can be computed on different nodes of the cluster. Spark uses RDD to achieve faster and efficient MapReduce operations. In this course, we're going to learn how we can work with resilient distributed data sets. Join me in the next lecture where we will continue the course. Hello everyone and welcome back to our course. In this lecture, we're going to learn what is a data frame. In this course, we're going to learn how we can build data frames with Pyspark, but first we need to know what actually is a data frame. A data frame is a distributed collection of rows under named columns. So you have rows and you have a header as well for each column. And each column represents a different property of the row, which represents an item. This may sound familiar to you if you've ever worked with data before, because this is the equivalent of a table in a relational database, as well as an Excel sheet with column headers. And a data frame is equivalent to a data frame in R or Python, if you've ever worked with those. The data frame of Apache Spark is different from a table, a sheet, or a data frame in R or Python, however, because it provides richer optimizations under the hood. So that's what makes it a lot more efficient. The advantages of using data frames are that they are designed for processing large collections of structured or even semi-structured data. They can handle petabytes of data, so those are very large amounts. As well, the Spark data frame has support for a wide range of data formats and sources. And the Spark data frame supports different languages like Python, R, Scala, and Java. And that is a data frame. Shortly, we are going to begin actually coding out a data frame with Pyspark. So join me in our next lecture where we'll continue the course. Hello everyone and welcome back to our course. In this lecture, we'll talk about what you'll need to take this course. There are very few requirements, but there are some things that you'll need. We will provide all of the source code for every single lecture, easily available just at the end of each section. And as well, we're going to show you how you can find and load data. You're going to find free data online. It's going to be historical stock data. And we'll show you how you can download that and start using it in your project. We'll also just provide that CSV file for you for reference in case you don't want to download it. All right, then as well, you will need beginner Python coding skills because we are learning Pyspark after all. And if you have no coding experience, then just make sure to watch the next section, which is going to be a prerequisite course, just a very quick section on how to code in Python. So that is a very valuable section. If you already do have programming experience with Python, then you can skip that prerequisite section and just jump straight into the Apache Spark and the Pyspark section. Database experience is not required, but definitely would help if you have any prior experience working with databases or spreadsheets, CSV files, or data. That would definitely help, but definitely not required because this course is for absolute beginners. As well, you will need a code editor with Python support, and you can get a free online code editor known as Google Colab. Just go to the link colab.research.google.com and you can start coding in Python with just your Google account. You won't have to install or download anything. Google Colab is what I'll be using in this course to build our project. You can load in your CSV file and build data frames all right there in Google Colab. You can also use any code editor you want that's on your computer if it has Python support. For example, Visual Studio with an extension to include Python support. So those are your two options. Either grab an online code editor to start coding on the web, or have a code editor on your computer with Python installed. And those are the few requirements that you'll need for this course. I'm very excited to take you through the course, so let's get started with our project in the next section. Hello everyone, and welcome back to our course. In this lecture, we're going to get started here in Google Colab, and we're going to start coding out our project. The first step of building our project is going to be to create our first Spark session. So first we have to install Pyspark. Here in Google Colab, our online Python editor, we can install Pyspark by accessing the terminal. So we're going to open a new code cell and use an exclamation mark to reference the terminal. And any line that we type after an exclamation mark is going to be treated like a console command. So I'm going to use pip install to install Pyspark. All right, and I'm going to run that code cell, and we will see that we're going to be installing Pyspark right into this file. And after it's installed, we'll then be able to access it throughout the whole Colab. All right, after we have installed Pyspark, we then have to import it, so we can do that right away. We can import Pyspark. And really, we only need to import the SQL module from it, because that is where we can get access to a Spark session. So we're going to import pyspark.sql, and then from pyspark.sql, we can access any of its sub modules or its classes. So in our case, from pyspark.sql, we need to import a Spark session. So this is the class Spark session that allows us to create a new Spark session. Awesome. Okay, now we've finished installing Pyspark, so we get the message successfully installed Pyspark. If you don't get a message successfully installed, then that means you ran into some issue, and just search up the issue online on a search engine or at Stack Overflow, and you should be able to find the solution to any problem. All right, so then we have to import Spark session. And once it's imported, we can then start using Spark session to create a new Spark app. I'm going to do just that. I'm going to call Spark session and use its builder and use the function app name. This is going to allow you to set your app name. We are going to call this, let's call this our first app. Okay, and then we're going to append the function get or create. This is going to either get the app if it already exists, or it's going to create it if it doesn't already exist. And we're going to store the result of this app in a variable Spark. So that way we can access all of its functions and different properties. If I run this second code cell now, it's going to import pyspark.sql followed by Spark session. Then it's going to get or create for me a new Spark app, and I can test if it got the value of the Spark app by printing out the value of Spark. Look at that, we get the result of a Spark session, version 3, master local, app name, first app. Awesome, that verifies that we have been able to successfully create a new Spark app. Okay, great, and just like that, we've launched a new Spark session. Next up, what we're going to do is we're going to find data online and then upload it here into this Colab as a CSV file. So that way we'll have data to work with. Join me in the next lecture where we will continue our project. Hello everyone, and welcome back to our course. In the previous lecture, we created a new instance of Spark here in Google Colab. We made a new Spark app. In this lecture, we're going to find and load data that we are going to work with to experiment with Dataframes. So for that, I'm going to visit the site finance.yahoo.com. Finance.yahoo.com allows us to get financial data, stock data, in the form of CSV files. And that is going to be very useful for us because we can then just load in that CSV file here in the Colab and convert it to a data frame. And then just like that, we can get up and running with experimenting with data frames. So let's visit finance.yahoo.com and search for any stock you want. I am going to select Alphabet stock, which has the symbol GOOG. So once you've visited that stock page for that exact stock, you can see all of the information about the stock, such as its current value and its history. We're going to click on this tab, Historical Data, because this is what allows us to download a CSV file of historical stock data. Select the time period. Typically 5 years is a good starting point for collecting data. The frequency is daily and we're showing historical prices. We can already see a preview of the CSV file right here on the web page. The currency is in USD. We have the date of the stock, its opening price, the highest price the stock went to that day, the lowest price that stock went to that day, the closing value of the stock, and the adjacent closing, as well as the volume of the stock. Hit this download button to download the CSV file to any folder on your computer. Make sure it's easily accessible. And the default name of the file is going to be called goog.csv. It's going to be called the stock key, the stock symbol, followed by CSV, because the format is a comma-separated values file, a CSV file. Hit save, and that is going to save that CSV file to your computer. Awesome. Next step, we want to grab that file and we want to put it into Google Colab because we want to be able to access it in Google Colab. So for that, let's create a new code cell and we're going to import from google.colab itself. We're going to import the files module. This will allow us to upload files right here into our Google Colab from our computer. So I'm going to then grab the files module and call its upload function. All right, now if I run this code cell, I'm going to get this prompt to choose files or cancel upload. Hit choose files, then select your CSV file, goog.csv, from your computer and hit open or enter. This is going to upload that CSV file to your Colab, so you can now use it throughout this Colab. All right, and you can reference it just by its name, goog.csv. You can already see a preview of the content right here. You should get this message, saving goog.csv to goog.csv. Okay, next, we are going to use Spark to read that CSV. And for that, I'm going to open up a new code cell, and I am going to call Spark my instance of a Spark app, and I'm going to use its function read.csv. This function, CSV, allows me to read a CSV and save it as a data frame. So for that, I am going to pass in a string, which is the name of the file, or the path to the file. In this case, the path to my file is just the name of the file itself, goog.csv, because that's how it's going to be stored relative to this file itself, goog.csv on Google Colab. If you're not using Google Colab, if you're using a different code editor, then you'll have to pass in the path to your CSV file relative to where it is on your computer versus where your current project is. Then we can also pass in whether or not we want the header, true or false, and if we want to infer the schema, true or false, which we do in this case. We're going to save that as a variable df, which is an initialism for data frame. So let's run that code cell, and Spark is going to read our CSV file of stock data. And you can just wait for that to happen. Great, okay, it's done. Then we can call df, and we can see we have a data frame type. We have several different properties corresponding to columns in our CSV file. We have a date, which is a string by default, the open column or property, which is a double, high, a double, low, double, close double, edge, close double, and finally volume int. So these are the properties in the data frame, and they correspond exactly to the columns that were in the CSV file. Awesome. Okay, Great, so this verifies that we were successfully able to find data to work with, and then to upload it here into our Python project, and then to use Spark to convert it to a data frame. Next up, we are going to learn how we can perform basic data frame operations with this data frame that we now have. So join me in my next lecture where we're going to continue our project. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to find and load data into our Colab file via Python. In this lecture, we're going to perform some basic data frame operations and functions. So starting with just getting the column names. So we can grab df.columns because the data frame type has properties and functions, one property being columns. And you can find all of the properties and functions if you read the documentation. So if I run this cell, I'll get the columns of the CSV file, date, open, high, low, close, edge, close, and volume. All right, next we can also print a schema of the data frame. So I'm going to call df.printSchema, a function this time. And you can typically tell a property will be a noun, but a function will be a verb. And here, look at this. Now we have all the column names again, but we get a schema instead of just the column names. So we have the root, which is the whole file. Then we also have the type of every single property, because this time every column is represented as a property. Then we can also print out rows. So let's go ahead and create another code cell here. And we're going to loop for every row in dataframe.head of a number of rows. Like let's say we want to print out the first 10 rows. We can then print out that row. You also want to print, well, line break, not necessarily. Okay, then we'll print it, and there we go. So if you add a line break, it'll just have an extra space. So here we have the first 10 rows in our file. And this is going to be starting from the very earliest date. That's how what we consider the first is the earliest. Okay, and we can see we have a row type and we have all of the properties of that row. So we basically get the column name and the value for that column. Awesome, okay. Next up, we can also use the describe function to get a summary of the data frame. So I'm going to grab df.describe and then add the show function here. Run that cell and we're going to see a summary. So here we have the count, the mean, the standard deviation, the min, and the max of every single column. Okay, so I'm going to zoom in so you can actually read the numbers. Here, we're starting with the date. The count of the date is 1,259, and it's the same for all the other columns because that's just the number of entries, the number of rows. Then we have the mean or the average. Dates don't have averages, so we get null. But then for number types, we can see we have the average of all of our columns other than date. And that average is just the average price of the stock over the past 5 years. We also have standard deviation. All right. And then we have min. For a date, the min is considered the earliest. But for numbers, of course, it's the smallest value. And finally, we have max. So we can see that the stock increased in value because in 2016, it was worth $671, but in 2021, it was worth $2,100 because we have here min and max. Awesome. All right. And those are just a few basic properties and functions that we can call on our data frame. Join me in the next lecture where we're going to learn how we can format our table. So I will see you over there. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how we can format numbers because currently, if we look at our data frame, our values are to very many decimal places, and we're going to format that to make it easier to read. All right, so for this, we're going to need to import a function to help us with that. From pyspark.sql.functions, we are going to import format number. All right, then we can put that to use. So I am going to call dataframe.describe again, and I'm going to store the results of that as my description. All right. Then I'm going to take the description and I'm going to select from it using the select function. And I'm going to select description, summary, followed by format number on the description at the open column, cast to a float and to 2 decimal places. As well, we'll add the alias of open. All right, let me zoom out so that you can see this. And after that, we're going to add the show function to show the results. So if I run this cell right now, look at this. We generate this little table. Okay, so we have described the data frame with that function describe, and we've selected the summary column from the description and the open column from the description. As well, the open column, we formatted it. We cast it to a float, and then we specify that we only want 2 decimal places. Awesome. Now, as well, we can add more columns. Okay, so we can get not just open, but we can get all the other columns as well. Let's do just that. Let's call format number again. And this time, I'm going to format the description at the column high. And I'm going to cast it to a float again, to 2 decimal places, and I'll give it the alias of high. Now, each function call should be separated by a comma. If I rerun this code cell, look at that. I now have a second column in my table, and also the numbers are formatted to 2 decimal places. We can do the exact same for all of the other columns that we want. We just have to call format number, then we grab the column we want. Let's do low next, and we cast it to a float and to 2 decimal places. Then we add an alias for the column, which will be low. If we run this cell now, we will have our 4th column, low, and everything will be formatted. Let's do the same, call format number on the next column, which is going to be the close or closing price of the stock. It will be cast to a float to 2 decimal places, and we'll add an alias of close. All right, and there we go. We'll run this, and look at that. We now have another column. Let's just do one more for the volume. The volume is going to be our description at the column volume, and volume is just a count. It's a count of the number of stocks. So we're not going to have it be a float because it's a count. It doesn't have halves or even quarters. So instead, we're going to cast it to an int type, because by default, all of these will be strings. So that's why we have to cast them. And the alias is going to be volume. All right, then we can run this cell. And look at that. Now we have our last column, and it's of integers now. Great. Okay, so that's how we can format our table, and also how we can cast the data types from the default strings. Because I can show you, if we print out the default, if we just call dataframe.describe and then we add print schema, we will see the data type of the data frame. By default, all of the values are strings. So we want to convert those values into number data types where appropriate, if we want to be able to perform some sort of mathematical operations on those. Awesome. Okay, great. Now that we have learned how to format our table and convert the data types, next step, we're going to learn how we can perform even more operations, and these are going to be more related to mathematical operations. So join me in the next lecture where we will continue our project.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.